So next, we are going to be looking at the SF6 insulated switch. So in a visual or mechanical inspection, we want to look at the nameplate information to see that it is as specified. Okay, so we are looking basically at two very important parameters: the rated voltage and the rated current. Okay, those are the two most important parameters that we'll be looking at. So in this case now, the insulating medium is SF6. Okay, so it is normally used for very high voltages, as you can see on this nameplate. Okay, so we also want to inspect the physical and mechanical conditions to see that there are no visible signs of damage, okay, to the mechanical parts. That is to all visible parts, even electrical. Okay, to all visible parts, there are no visible signs of damage. So we will check the anchorage to see that it is firm, check the alignment, check the grounding, and other required clearances that it meets what is recommended by the manufacturer of the equipment. We also want to see that the equipment is clean. We also want to see that the mechanical operators, okay, that they are okay. I want to inspect them in accordance with what is recommended by the manufacturer of the equipment. So we want to verify the correct operation of the pressure alarm of the SF6 gas. Okay, so that we want to do by checking that the alarm system is actually functioning properly. So we want to see that in the alarm system, every component, they are functioning as recommended by the manufacturer. If any of them is due for changing, we change them at the appropriate time as recommended by the manufacturer. Whatever test that is recommended by the manufacturer, we want to do that at the appropriate time also. So we want to verify that all the critical distances on the operating mechanisms, they are as recommended by the manufacturer. That is the next thing we want to do under the physical check. We want to also look at if there are interlocks. We want to see that they are properly sequenced as recommended by the manufacturer, okay, and that they are working perfectly. Mechanical interlocks, okay. Then the distances, tolerances, clearances, and what have you, we want to be sure that they are all as recommended by the manufacturer. Okay. We want to lastly verify the operation and sequencing of the interlocking system. We want to see that they are also as recommended by the manufacturer. Then if we have fuse odor, we want to see that they have adequate mechanical support, and the contact integrity, we want to also be sure that it is firm. The fuse size, we want to see that it's accordance with what is specified, and is in accordance with the short circuits and the coordination studies. So the lubricant for those parts that are visible either in the operating mechanism or the current carrying part, we want to be sure that we use the recommended lubricant on all moving parts. Okay. Then we want to also test for leaks, for SS6 gas leaks. Okay, so we want to do that in accordance with what is recommended by the manufacturer. Then whatever we see before and after our inspection, we want to recommend or we want to record all. So the final test that we'll be doing is the electrical test. As usual, we are going to carry out the low resistance test. Okay, We'll do it at all connection points as we have earlier discussed. We'll also do it at when the contact is closed so that we'll be able to record the contact resistance. Okay, so when the contact is closed, okay, once the contact is closed, we'll record the contact resistance by probing the exposed end between, okay, the exposed end, which means that we are measuring the resistance between the contacts. So that's what we want to do. And then we'll also measure the insulation resistance between phase and ground to see that we have the appropriate insulation on the unit. Okay. So if we have what is recommended, fine. But if not, we can use this table as a guide. So we also want to take sample of the SF6 gas and then analyze that sample. And that sample, the test should be in accordance with what we have here. We'll test for moisture. Then the SF6 decomposition byproducts, we also test for them. Test if we have air ingress, okay? Then the dielectric strength of the SF6 gas. Those are some of the things that we test. So here are some of the methods that we use. The hygrometer, okay, for the decomposition byproduct, we will use the ASTM D2685 procedures or standard, okay. Then what we expect for the moisture level, okay, it should be less than 200 parts per million. Okay, if it is equal to 200 parts per million or less, that means we need to do something. We want to verify the reason why and make the appropriate or necessary correction. So if the decomposition product, okay, is that is sulfur and fluorine, is greater than or equal to 500 parts per million, we also want to check to see the reason why it is so and then make the appropriate, okay, that is either to recharge the system or try to verify why we have that kind of decomposition. Then if the air content is also more than 5,000 parts per million, remember all of this will have the effect of reducing the insulating capacity, the insulation resistance of the SF6 gas, and thus the possibility of creating problems for us during normal operation is there. So we want to be sure that it is not up to all of these levels, should be less than these levels. Then the dielectric strength of the SF6 gas should be between 11.5 to 13.5 kilovolts, okay? Should be between those range. The higher the better for us anyway. So if the dielectric strength is reducing, that means that the insulating capacity of the SF6 gas is coming down. So we need to do all we can to ensure that we restore that back to what is recommended. So next, we need to perform the dielectric withstand voltage test across the phases and then between phase and ground, as we said earlier. Okay. So we also want to do that to see that we have the appropriate insulation or withstand voltage level when we open, or when that is when the switch is open and when the switch is closed. So the control devices, we also want to initiate their operations to see that they are operating appropriately. So here is a recommendation as we saw earlier. The far left, here we have the nominal operating voltage, the class of the insulation. So this is for factory acceptance test. We will not be involved in this since we already have it in our facilities. So here we have the AC. If we are using AC voltage to do the test, the maximum voltage that we need to apply, and if it is DC, the maximum voltage that we need to apply for the various nominal voltage ratings of the equipment.